This is a Bitoroid wound, 200 turns, 100 turns for the pulse width generator, and this one has 390 turns. Each end, this is the primary, this is secondary. Each end is a one white LED with a 1K ohm resistor attached to it so I don't burn them out. This modulator frequency generator is set at medium frequency right now, but as I tweak up the pulse width, you'll see this one has more winds, almost twice as much as that one. So you'll see the difference when I tweak up the timing on it. Once I find the pot here. Okay, see the right one and the left one's brighter, but as I tweak it up, you'll see that the other one goes brighter and the left one goes out. Now I can balance them out with the pulse width timing. As I turn it, see, they're both bright, but as I lower it now, you'll see the one on the left stay on and the right one goes out. And when I turn it up high, the one with the more winding you think would be brighter, but it's not. And this is real low current, like about 400 milliamps to run it. I could switch and you'll see what happens when the switch is off and they get real bright and go dim. That's due to the capacitor I have here in the pulse width modulator. It's draining out. And you see it changes the frequency when it goes high or low, and then I can change it over here on the, I have a variable power supply. See, I'm turning it almost off. 7 volts, 8, 9, 10, 11, 12, 13, 14, 15. Not much change, but when I turn it way down, the right one wants to go brighter. There's about 7 volts to run it right there. So if I go high frequency, the left one stays on. If I go low frequency, should be getting a flash here, but I'm not getting nothing right now. Anyway, medium, high, medium, going at 12 volts, 7 volts, 8, 9, 10, 11, 12. Actually 15, I mean. Now I go low. It's enough power to run the flashing circuit. It's a real low frequency. Medium, high. They vary with frequency and voltage, but most of the power is going to the primary, which is in the center here, and the secondaries probably get the same amount of energy, but the windings are going to make a difference in the current coming through, and the frequency should remain the same. You could hear it. If I turn it up, the frequency should go up too. Yep, you can't hear it no more. More like 60 hertz there. Closer to 60 hertz. But I notice if I change frequencies and it's out of resonance, the heat sink gets pretty hot over here. Not with this circuit though, but with other circuits. This one can't take much energy anyway, so there's high frequency, medium, low. Let's see, low, medium, high, medium, low. Cranking it up to about 12. Medium, high, medium, low. And that's all. See if I turn up medium. turn it off, go to low again here, give it some volts, turn it off. The cap ain't discharging it this time, but it was. And that's all. And that's what I have. This is a Bitoroid, about 24 gauge, somewhere wire on all ends here. One MOSFET generator with a Lawton PWM circuit here, with 3 frequencies in with the dial here. The switch should go to 3 different frequencies. And that's what I have for that. And we'll be ending this.